All right, and welcome to Lesson B, the applications of Venn diagrams. And I'm sure everybody's seen a Venn diagram at some point in time or another. It just is a good pictorial representation of the relationship between sets. And sometimes that involves the universal set and maybe a couple of sets A and B. And that's the examples that you see here in the pictures. The relationship could be where they have some elements that they have in common, or they have no elements that are in common, or they have one set like A which is entirely within set B, and the universal set is everything else that's outside of B. So I encourage you to watch the other two videos that are going to be on my website about how you can shade Venn diagrams. Those are going to be for the problems that we look at for the homework, and also some of the other problems will appear in this particular video right here. So let's kind of go through some of the questions that we have here. Is A a subset of B? And I'd have to say that no, A is not a subset of B here in the first diagram A. See, these A, B, and C refer to these three pictures. A is not a subset of B, and A is not a subset of B in figure B there, but A definitely is a subset of B in figure C here, and region number 3, it is named region number 3. That is the region that names that subset. So is B a subset of A? Well, in each case the answer is no. B is not a subset of A. Because to be a subset of something, you have to have all of your elements contained within the larger set. And some of the elements that are in B are in A, and vice versa, but not everything. Okay? Do A and B intersect? Well, in the case of figure 1 over here, figure A, the answer is yes. And region 3 is the region that names that intersection. A and B don't intersect in the middle figure. There's no overlap whatsoever. And A and B do intersect in this third figure right here. Sorry about the mess. There we go. And region 3 once again names that intersection. Would it be easy to find the union of A and B? Well, sure, yeah, absolutely. It would be easy to find the union. What region or regions name that? Well, the union is all of the sets put together. So 2, 3, and 4, everything that's in any of those regions, that's part of the union between A and B in the first diagram. If you just take region 2 and region 3 and put them together in the other two diagrams, that is what names the union. And lastly here, the other question is what names the complement of A? Well, that would be everything that's outside of set A. So you got to look carefully here in figure 1, because everything that is outside set A is in either region 1 or 4. It's not in 2 or 3, because part of 3 is still part of region set B, of course, but it's still part of set A. In this particular case in the middle, everything that's outside of A is regions 1 and 3. And everything that's outside of A in this particular Venn diagram up here for C, that's regions 1 and 2. So hopefully being able to kind of tell where intersections and unions and complements all live, that's going to be part of the big task of this particular situation here. So coming down, you can also use a Venn diagram to kind of number certain things or give an idea of how many elements are in each set. So for example, you've got a researcher that collected data on 100 households rather. 76 of them have a DVD player, 21 have a Blu-ray player, and 12 have both. So if I wanted to draw a set here, or a Venn diagram that models this situation, I could call everything that's in the rectangle my universal set. And that would be all 100 households that I have surveyed about this. And I could call this first circle on the left set D for DVD players, and on the right I could call it set B for Blu-ray players. And you notice there's an overlap here, and the reason why there's an overlap is you have 12 households that have both of them. So I'm going to put 12 right here in the middle, and you'll see some homework problems like this, and probably some test problems too, where you will have to use a Venn diagram in order to establish a relationship between things. Now, we've got set D here, and it's kind of fair of me to point out that set D not only includes the people that have a DVD player, but also the ones that have both. So that's why I'm kind of highlighting this right now. I'm going to take the highlight away in just a minute. But if I know that 76 households have a DVD player, well, I have to include those 12 that have both, because they have both a DVD and a Blu-ray player. So I have to figure out how many just have a DVD player. And if this number inside the circle of D has to total 76, then I have to subtract 12 from 76. Oopsies, let's get the right tool here. To get 64. So there are 64 households that have a DVD player just by itself and 12 that have both, for a grand total of 76. Okay, now what about the Blu-ray players? Well, the Blu-ray players total 21. Now keep in mind that once again, this is a situation where you have some are in the intersection and some are in just the set of B itself, the set of Blu-ray players owners. And if there's 21 total and 12 of them are in the intersection, then that means that another 9 make up just people who have a Blu-ray. So 64 have only a DVD player, 9 only have a Blu-ray player, and 12 have both. Okay, well let's add these numbers up here. And then 64 and 12 is 76. And then if I add another 9 onto that, that's going to give me 85 as a total. Okay, but the problem is I surveyed 100 households. This only accounts for 85 of the 100 households. So the other 15 must not have any type of device. And I'm going to put that number 15 out here in the universal set, but not in any one of those. So that way it's going to be something that I can look at later and say, oh, okay, well 15 households don't have any of the above. All right, so that's kind of a quick intro on that sort of thing. Now let's kind of add to the excitement here a little bit. Let's talk about if you have 3 sets. And you can still do this if you have 3 sets. It's just a little bit more complicated. And the catch is going to be to kind of start in the middle and work your way out if you can possibly do it. So these are like little logic puzzles that you can use to figure things out. So you've got 77 business students at a local university, and if you surveyed them, you see the publications that they could read or do not read. Business Week, the Wall Street Journal, and Fortune. So I'm going to take this circle in the upper left and I'm going to call it set B for Business Week. And the one to the right here, I'm going to call it set W for the Wall Street Journal. And then down here, we're going to give this one an F. Yep, it failed. No, F for Fortune, of course. And as I look through the clues here, what I'm going to start with is I'm going to start with the one that has the most information right away. And I have to put that in a spot on my Venn diagram here that represents that. So you notice that this area in the middle right here is where all 3 sets overlap each other. Where set F, set W, and set B, they all overlap each other right in the middle. So if a student is in this middle part of the Venn diagram, that's because they read all 3 magazines. So you notice that 9 read all 3 magazines. So in using that clue, I can just put a 9 right in the middle of all 3. And now I can start working backwards, kind of like I did with the DVD problem, and see if I can fill in some appropriate symbols here. So 13 of them read Business Week and Fortune. Well, 9 of them read Business Week and Fortune, plus the Wall Street Journal. So if 9 of them definitely read Business Week and Fortune, but there's 13 total, then in this spot right here, where Business Week and Fortune meet, but the Wall Street Journal isn't included, I'm going to put a 4. And that'll take care of that clue right there. So you notice I'm sort of working my way backwards from the most specific information to the least. All right, so 11, read the Wall Street Journal and Fortune. And again, let's kind of focus in on this area right here. This would be the Wall Street Journal and Fortune both, that area that I just zapped in yellow. So let's get rid of the yellow streaks here. And I might note that there's 9 of them in the middle, but 11 should occupy this entire little wedge. So that means I have to put a 2 right there. Okay, so that takes care of that clue. That means I'm going to have 9 and 2 makes 11 for the 11 that read Wall Street Journal and Fortune. All right, so I'm going to keep going here, and it says 11 read Business Week, but not the Wall Street Journal. Okay, 11 read Business Week, but not the Wall Street Journal. So if I'm highlighting an area where I'm going to have students that read Business Week, but not the Wall Street Journal, it would have to be somewhere in here, because this is the part of Business Week that doesn't have anything to do with the Wall Street Journal. And that's where I get this particular highlighting from for just a moment. So I'm going to get rid of that, so now that we know where it is, I know that 11 students read Business Week but not the Wall Street Journal, and if 4 of them are already accounted for in this part of the wedge, then means that the other 7 still need to be accounted for right there. And now we're getting closer to our goal here. Okay. All right, 27, do not read Fortune. Well, that's not a very helpful clue at this point, because I'd need to know some more information to be able to use that. So I'm going to come back to that one later. 19, read the Wall Street Journal. Again, in order for me to fill in a number for sure, I can't really use this 19 total until I have more information about one of these wedges. So let's move on to the last clue. 25, read Business Week. And if you focus in on just the Business Week set alone, well, you notice that there is all the wedges filled in for Business Week except one, this one right here. So 7 and 4 is 11, and another 9 is 20. That must mean that if 25 students read Business Week, that must mean that a 5 has to go in here in the wedge, in between them. Okay, getting warmer again. That kind of takes care of that clue. So now what about the Wall Street Journal here? Well, we know 19 read the Wall Street Journal, and I've got enough information to be able to fill in this little part of the Wall Street Journal set. There's 16 students that are in some intersections here, so that means 3 and only 3 read the Wall Street Journal alone. Okay, so now I'm left with 27 do not read Fortune. All right, well, I know that I have, if I'm talking about not reading something, that's kind of like talking about a complement. So let's kind of focus on set F here for just a second. If 27 do not read Fortune, then that means every one of them outside of this circle. So 7 and 5 is 12, and another 3 is 15. So that means another 12 students are in the universal set and don't read any of these magazines at all. So 7 and 5, or newspapers also, so 7 and 5 is 12. There's the 3 for 15, and then 12 makes 27. So that takes care of all of our clues, but I still have a wedge left. And the way that I'm going to figure out how much goes in this particular wedge is I have to add all these numbers up and take them away from 77. And that'll tell me how many people read Fortune. And Fortune alone, I should say, without being in an intersection. So there's 12, there's 15, 15 and 2 is 17, 17 and 9, 26, 26 and 4 makes 30, and 42, but there were 77 total. So I need to do 77 minus 42. And if my math is correct, I'm going to come up with something like 35, I believe. So I have 35 students that read just Fortune alone, and I have a bunch more that read some combination of publications. I've got 12 that don't read any, 7 that read Business Week alone, and 3 that read the Wall Street Journal alone. All right, so I hope that was a helpful problem for you, and it really gives rise to something called the union rule, which we're going to revisit. So let's kind of come back down here and answer these questions. The number that read Business Week, if we go back up here, the total number that read Business Week is 25, and we got that from the clues. And the number that read all 3 is 9. We got that from the very first clue that we used. Okay, so that kind of helps to describe the number of elements in a certain set or subset here, this N notation. All right, so let's kind of talk about another example of this union rule here, where you want to think about a universal set being a deck of cards. If C is the set of clubs and D is the set of all face cards, how many elements are in the union of C and D? Okay, well, let's think about the number of clubs that there might be in the deck, and the card players who are watching this know that out of the standard 52, 13 of them are clubs. And the number of face cards is going to be 12, because there are 4 suits altogether, and each of them have a jack, a queen, and a king. So 4 times 3 is 12. Now, unfortunately, what we've done here is we've done something that's called double counting. And what I mean by double counting is we have to now realize that we've counted all the clubs, including the face cards, and we've counted all the face cards, including the clubs. So that means the 3 cards that are clubs, and here comes my gruesome little club symbol. Okay, the 3 cards that are clubs, that are also face cards, they belong to both sets. They belong to both. So those 3 cards I have to take away, because if I don't take them away, then I've double counted them in either one set or the other. So there's really 22 cards in the deck that are either face cards or clubs. So what I had to do is I had to take away this number that was in both sets. So if you remember this from a previous video, if something is in both sets, that means it's in the intersection of both of those sets. So the union rule is going to be you take the number in each set, and then we have to take away the number that is in the intersection of those 2 sets. And the reason why is because you don't want to double count. You don't want to accidentally overcount your cards, because it's going to be kind of hard to do that. I mean, if you were to actually physically get out a deck of cards and say, okay, I want all the clubs and I want all the face cards, then you would see that there are 3 cards that fit both categories very easily. And sharing them is not necessarily an option here. That's why we get only 22. Okay, so hopefully that is a good introduction here. We're going to see if we've got any. I think this problem up here at the top is a challenge problem on the next page of notes. I'm going to skip this because from what I recall, this did not make any sense whatsoever when I've done it. So we're just going to skip right over that. I hope this has been a helpful tutorial. Go watch the other 2 videos and then tackle the practice problems, and good luck to you.